So this is lab for magnetic fields of a bar magnet. So the main objective is to measure the distance dependence on a bar magnet. So basically we're going to find out what n is in this equation over here. And we do that by looking at our data. And yeah. So the secondary objective is to measure the magnetic field at an off-axis location and compare it to the law that we created in Gross script. And the materials that we're going to use are the bar magnet, a cell phone with a magnetometer app, and a meter stick. So our experimental setup. So first this is made up of two parts. So we compensated for magnetic north, which basically means that we basically rotated the phone until Vx was as close to 0 as possible. And so then we aligned the meter stick along the east and west axis. So Vx was the only reading that measured the magnet. Or like the reading was like the only thing that we could pretty much get out of that. So next, we had to locate the magnetometer sensor, and we did this by using the bar magnet to find the exact spot on the phone with the strongest field. And we found the line of Bmax, max Bx, then rotated the phone 90 degrees and find the line of max By. And the intersection is the sensor location. Okay, so the procedure, and what do I got? So the procedure, we placed the magnet on the east and west meter stick, and then we found the recorded distances that produced the Bx values of 20, 70, 120, 170, and 220 microteslas. And we basically found, this spreadsheet pretty much does it for us, but it creates a straight line between, when you take the log of this equation here, you pretty much get a straight line, and this is the plot. And from what I get from this is the magnetic moment will be 2.62. Okay, so the off-axis field. So we're going to compare the model and the observation data that we got. So what we found on the axis distance, it was 100 microteslas. And the measured distance was 0.187 meters, and then we moved the sensor to the off-axis position where it's at a 45-degree angle. We measure the net field B net and corrected the y component to account for the Earth's y B field. And from that we got 22.5 microteslas. So from this we can pretty much say that we were pretty close because we got an observed value of 18 versus 22.5. So not bad at all. And this is the glow script. On the right we have the code that I created for the dipole. And on the left we have it shows the V perps for everything, and then yeah. So coming out of this, we have to make some assumptions, and identify sources of errors. I think the two assumptions I could come up with were pretty much that the bar magnet behaves like an ideal point dipole, and setting the experiment so where b not x, or sorry, not just bx was 0. And sources of errors, we might not have found the exact center of the sensor. It could have been a bit off. And during measurement, or carefully placing the phone down where it should go, it wasn't completely stable. And what if we didn't account for magnetic north? The plot that we had wouldn't be a straight line anymore, since the B field would have a component on the x-axis. And what if we use two identical magnets end to end? I'm pretty sure that it would just double, so then the distance r would be twice as strong, or the magnetic field at any distance r would be twice as strong. But the slope would probably, I'm pretty sure, would stay the same for n. Alright, thank you.